Okay, we're on another day of 4-3. I don't know what day it is, but you should already have this written down, correct? Okay, so I told you at the bottom the Pythagorean identities that sine squared plus cosine squared equals 1. You will know that, and we're going to develop the other two so you know where they come from and can make a connection with them. So that's where we're going to start today. But the biggest thing is it is sine squared plus cosine squared equals 1. It is not cosine plus sine equals 1. They are what? Squared. Okay, they are squared, and that's important to remember because if it's not squared, it doesn't work. Okay, so we are going to start. They are both sine squared plus cosine squared equals 1. You see that?
Yes.
Okay, we are going to start on this one over here. And we're going to simplify it. We're going to manipulate it. So we are going to start by dividing everything by sine squared. So sine squared divided by sine squared is what? 1. Plus, well, cosine over sine is what? Cotangent. So we now have cotangent squared of theta. And 1 over the sine of theta is cosecant. So that's how we get the other Pythagorean identity.
That's weird.
Why?
I don't know what this.
Okay. We can move this around. I could, so you don't really need to write this if you don't want to. Could I write this as 1 equals cosecant squared minus cotangent squared? Yes. Could I make this cotangent squared equals cosecant squared minus 1?
Yes.
Yes. All I'm doing is using my algebra techniques to move this around, yes? Okay, we will be manipulating identities. These are identities, trig identities. We will be manipulating them, and you'll need to realize that anytime you have a squared, the first thing you should be thinking about are the Pythagorean identities and does it fit in there? So you'll have to manipulate these to change and to do what we're going to do. Is there another way I could write this at all?
No.
What if I just wanted cotangent? I'd have to take the what of both sides? The square root of both sides. So the cotangent of theta would equal plus or minus the square root of cosecant squared theta minus 1. How would I decide whether it was positive or negative?
Whatever, like.
The quadrant. What quadrant I'm in, right?
Yes.
So cotangent is positive in the first and the third, right? Where both signs are the same of sine and cosine. Both x and y are the same. It is negative in the second and fourth. And we'll start venturing out of the first quadrant here pretty soon. So that plus or minus is determined on which quadrant you're in. So then we divided everything by sine. So now we should probably divide everything by what?
Cosine.
Cosine squared.
Squared.
So cosine squared, and cosine squared. So sine squared divided by cosine squared is?
Tangent squared.
Yep, tangent squared. Plus 1 equals, and 1 over cosine squared is?
Secant squared.
Secant squared. And can I do the same manipulations with this as I did with the other one?
Yeah.
Could I do the same manipulations with cosine squared plus sine squared equals 1? Yes? You notice I put cosine squared plus sine squared. Does it matter which order they're in?
No.
No, because it's addition, correct?
Yeah.
So if I wanted just cosine in terms of sine, I'd have to do the whole square root thing, right? I'm just manipulating it with the algebra that we already know. It's important to realize that on this one, it's 1 minus sine squared, correct? See that? On cotangent, it's cosecant squared minus 1. Does it matter which order it is in? Why? Because it's subtraction, not addition. Yes?
Do we have to write all the
No,
different
you do
like-
not.
Wait,
You need to have this, because we should know that we could do all the rest with it. I would not write all that down because you think that you have to remember it all. You need to remember the original. Okay? So these three are the Pythagorean identities that we need to remember. Now, I pointed out the other day, and you probably don't remember, what is in the denominator of cotangent? Sine. What is in the denominator of cosecant? Sine. That's how you remember they go together. Because usually people can say, okay, I know it's 1 plus cotangent or tangent, and they don't know which one's on the other side. Okay? So cotangent has sine in the denominator, so cotangent and cosecant are paired together in those identities. Tangent has cosine in the denominator, so tangent and secant are paired in that identity.
so pretty much to get the other formulas, you just divide them by the other things.
Yes. So in all actuality, it started off with this identity, and then they just proved other ones. Okay. So you won't have to build them. I just wanted to show you where they came from to make it a little easier to remember. So use trig identities to transform the left side of the equation into the right side of the equation. Now, we are going to be doing, these are called trig identities. You're going to be proving. You're going to go left to right. Sometimes you'll go right to left, but today I think it says left to right. There's some things you need to know. The equal signs need to be lined up as you go down. What does that remind you of? Where else do we line up things? The Gauss,
Brackets,
when we did the
brackets,
Gauss-Jordan, right?
numbers, Yeah.
Okay, so we need to do that. We are not solving. We are simplifying one side to make it look like the other. Okay, so when I solve, I can zero things out and move them to the other side, correct?
Yes.
Okay, we are not doing that. We are simplifying. So we're taking this left side and using identities to simplify down to, you already know what the answer is going to be, basically. Does that make sense? You can't add or subtract something to the other side. You can't multiply both sides by the same thing. You can't do the things you would do in solving. Okay? So always make sure you have plenty of room. The way this presented on there, so I'm really kind of scared about lining this one up, but I think I'll be okay. Make sure you have room to write. I know I will take people that, I have people that all the time will reverse this and make it 1 equals sine of theta, cosecant of theta, because then they can easily line them up and move things to the right because things tend to get bigger before they get smaller. And you'll figure out some things that you want to do as well. Okay, so it says make the left look like the right. So we need to use our trig identities. Well, sine is pretty much sine, isn't it? Okay, unless it was squared, then we could be thinking about Pythagorean identities. Cosecant, that's it. The reciprocal is sine. So my next step would be sine times 1 over sine.
Oh,
Now you notice I didn't put the thetas there, did I?
no.
Okay, the thetas have to be in the initial and they have to be at the end. If you don't want to put them all the way in between, you don't have to. This is a very quick and easy. Most of them will be 2 or 3 steps today. We will get in more complex proofs as we go along. Okay, and we don't show our work. Okay, we are big kids. We should know that sine and sine reduce, correct? So what does sine times 1 over sine equal? 1 and 1. You do not show crossing things off. And then to end it, we do our little mic drop, our little It is a square. Some books put a little triangle. If you actually go look at your textbook, every single example has a little box at the end of it. Every single one. Every problem you do is technically a proof. So what you've done here with the little box is say, I'm done, now prove me wrong. Okay? If you don't like what I'm doing, prove me wrong and tell me I'm wrong. We're not wrong, are we? Did we make the left look like the right? Okay, next problem. Cosecant of theta plus cotangent of theta equals cosecant theta minus cotangent theta equals 1. Okay? The first step you will always do is write the problem on your paper. There's no ifs, ands, or buts on this. This is what we're going to make our left look like our right. If you want to put the 1 on this side, you can, because it will be easier to line those up. I don't care, but we're making this left be 1. Again, I write my equal sign first, so I know where I can go. You notice that I didn't keep writing the 1 on the second step, did I? If you're not changing a side, you don't need to keep writing it. One of the last techniques you do are change both the left and the right to make it look like each other. But today, everything should nicely work out where the left turns out like the right. They're nice to you at the beginning. So, what do you think we should do there?
I think we should multiply them.
Okay, why do you think you should multiply them, Kale?
Because you'll get a Pythagorean identity.
You'll get a Pythagorean identity. And do you guys see that those are conjugate pairs up there?
Yes.
So that middle term's going to be gone, isn't it? It's going to be the first term. So I have cosecant squared theta minus cotangent squared theta. If you need to actually show all your math for yourself, you need to do it off to the side, not in your proof. Okay, so in your brain, you should be going Pythagorean, Pythagorean, Pythagorean. Why? Why should those alarms be going off? Because they're what?
Squared.
They're squared. Okay? They're squared, so I should be thinking Pythagorean, Pythagorean, Pythagorean. So, what is the Pythagorean identity that has cosecant and cotangent in it?
It would be
1 plus cotangent squared theta equals cosecant squared theta.
Okay, so is it going to be advantageous, we're going to use our ACT prep in here, for you to learn these as soon as possible?
No.
Yes. Now, if you need to write it down, because you're like, okay, I know it's there, 1 plus cotangent, the denominator of cotangent is sine, so cosecant, so 1 over sine, so, okay, I got it. Did I look at my paper? No. Did I make my brain think about it?
Yeah.
Yes. Make your brain think about it, because if you just take the easy way out and constantly look at your paper, are you going to be learning your identities?
No.
No. So, how can I move this around to make it look like what I have over here? So I obviously need to make it equal to 1, yes?
So subtract the cotangent over.
So subtract the cotangent over there. So do I get what I have up there?
Yes.
Yes. I have cosecant squared minus cotangent squared, so this equals what? 1. Equals 1. And am I done?
Yes.
Yes, the left looks like the right. I don't write any of that because this is identity, yes? Now, this is my deal for you. As long as you are doing one step at one time, I don't make you write why. Does that make sense? Once you guys start trying to do 2 steps at one time, I make you start justifying every single step. With this would be Pythagorean identity. And then when you get to 4 or 5 steps, you'd say reciprocal, multiplication identity, multiplying by reciprocal. Do you want to start listing all that stuff out? Nope. So, 1 step at one time. Not multiple identities in a step. Now, you could use the reciprocal identity all you wanted. You could use it 6 times in one step because what did you use? Reciprocal identities. But you can't use a reciprocal and a Pythagorean in one step. Does that make sense what I'm saying? So far you haven't had to do that, but Again, left look like the right. If you want to swap how you're writing it, I don't care. Tangent of theta, cosecant theta equals secant theta. Try it on your own. Look what you've done in different problems. We've done 2 problems. You might want to use the same things we did. Period, you're done. It's a mathematical equivalent to it.
I don't know what to do. Is that either one?
What did we do on the first one? Last time.
I don't know. No one knows.
No one knows. No one knows how you went from cosecant to 1 over sine.
Sorry, I won't say anything.
Look at your paper. How did you go from secant to 1 over sine? What did we use?
It would be reciprocated.
It was reciprocated. We used the reciprocal identity. So here we probably should use the what? Reciprocal identities if we can. So cosecant is what?
Cosecant is sine.
1 over sine.
1 over sine. Okay? So 1 over sine is cosecant, correct? Well, we want to have secant when we're done, yes?
Yeah.
Which would be 1 over what?
Cosecant.
Cotangent. So we probably want to change tangent into what over what to get rid of the sine. What is tangent?
Sine over cosine.
Sine over cosine. Tangent is sine over cosine, or is 1 over cotangent, correct? Is 1 over cotangent going to help me here at all? Do I want cotangent on the other side? No. So we're going to change it into sine over cosine. So the signs reduce, and I have what? 1 over, I can't skip yet because I had to reduce it. You have to show that reducing. So what is 1 over cosine? Secant, which we wanted to have. So I have secant theta equals secant theta. Then I put my box. The box is the statement that says, I am done, I've proved it. Now you find my errors.
Just hope we don't have any errors.
You don't have any.
You don't.
Because your left side looks like the right.
As long as you didn't be creative at all. Now, you said 1 over cosine, so I had to show that simplifying, I had to show that multiplication property. So I got 1 over cosine, and then I came here. You need to keep your eye on the prize, what you're looking for, and then what can you do? Now, turning everything into sine and cosines right away isn't always your best bet, but if nothing else, do it. Okay? Try something. So I have cosecant theta plus 1, cosecant theta minus 1. What do you think we should do? Multiply it. So do it. I could change that into 1 over sine before I multiplied, but it really is not going to do me any good because I want what at the end? Cotangent squared. So you should see that those are conjugate pairs, so you shouldn't have to multiply it all out, correct? You all see those are conjugate pairs. So you should have gotten cosecant squared theta minus 1. So what identity should I be thinking about? It's
Pythagorean.
the Pythagorean. It's squared. So Pythagorean should be what I'm thinking about. So I've got cotangent. Well, 1 plus cotangent squared is what? What's in the denominator of cotangent?
Well, no.
Sine. So it equals cosecant. You were skipping. So I have 1 plus cotangent squared equals cosecant squared. Can I rearrange that to look like cotangent? If I did, it would be what?
Cotangent squared equals cosecant squared minus 1.
And is that what I have?
It sure is.
So our left side equals,
Cotangent squared.
oops. So you just make your equal signs bigger if they don't line up. And then we put a box to say we're done. So I had to write it down to manipulate it a little bit, but I did it somewhere else, not in my problem,
Oh, I was confused why we did it down there.
because it's not in the problem, it's in our head.
Yeah.
So these are a puzzle, guys. And we all know that everyone does a puzzle differently, correct? Okay. Who does the outside first on a puzzle? If I gave you a jigsaw puzzle.
Like most.
I think
Okay, most people do that. Okay. And then what does somebody do next? Somebody else tell me what they do next after they do the outside.
puzzle together.
I just sift until I find stuff that looks alike.
Okay. I do the same thing. I look at a color and I'm like, ooh, this is a lot of that color. And I put it there. You know, my daughters do jigsaw puzzles, drives me nuts. They do all the edges and then they look at the picture and they're like, I want that piece. And they go through the whole box of 1,000 till they find one piece.
Yeah, they're very
Okay.
good.
That takes forever. Okay.
Isn't that the point of a jigsaw puzzle?
No. Point is to see how fast you can do it. What I'm trying to tell you is people do things in different order. Do we all do about the same thing the first time? Yes. The first thing? Yes, you do your edges. So on these, you're going to look at it. On these, you're going to look at it. The first thing you're going to do is, what do I need to get it to? Today, you don't have a choice. Left looks like the right. In a week, I'm not going to tell you. I'm going to say, prove it. So your first thing is, do I work on the left or do I work on the right? So you will develop those skills as we go along. I'm going to tell you right now, though, if you make me give you the first step every time, you're never going to learn how to do these on your own. Because you have to make a decision. Those are for tomorrow.
Yay.
Let's go.
Okay, get to